Right, maths is magic. Right? We said it and we'll say it again. And I know that magic in maths is going to transform you into a dynamic leader. The confidence you get as you move along, that's the beauty. And I want you to hold my hand. Yeah? I'm not going to dance with you. We're going to do what dance? Rate of change. Right? Let's go and draw the graph. What is this question all about? Well, they said, from the given distance time graph, draw the speed time graph and comment on the distance time and the speed time graphs. They say comment. This is about show and tell. You know what I mean? You're supposed to perform, participate and perform. In Singapore schools, now the trend is to do PP. What's a PP? It's not a people, but it's perform. Participate and perform. Right here, you've got to be participative. You've got to draw this graph. What do? Look at it and say, hey, read the graph. Right? Distance measured in kilometers. Here, time measured in minutes. So the slope is showing us, what is it? Speed. This is speed 1, this is speed 2, this is speed 3. But in speed 1, you moved 5 kilometers in 8 minutes. It's a constant speed. So we said, hey, S1, the speed is 5 kilometers in 8 minutes. So you get about, okay, if you divide 8 by 5, you know I taught you the caterpillar division. Long ago, if you've seen my earlier clips about not being a nerd, about being speed calculation, check it out. I did this beautiful caterpillar to show you how fast we could do it. Dung dung, 0. Carry the 5 up, you get a 6. 48. Carry the remainder 2, you get a 16. And the remainder is 4, you get 0.625 kilometers per minute. That's what you get in speed 1. Oops, let me get my duster. Right. So that's the first part of the speed. You're moving at 0.625 kilometers per minute. Next, what is speed 2? Is there a speed? Oops, resting. Right, it's a resting. No distance is traveled. If you don't travel and you're standing still, is there a speed? 0. Yes, good. It is 0 kilometers per minute. Good. And how about S3? Right? The speed is different now. Let's find out. From 5 kilometers, they move to 9 kilometers. So if you look at this distance, there is a distance moved of 4 kilometers in how many minutes? From 12 to 18. So it took 6 minutes to do it. So the speed is 2/3 kilometers per minute. And 2/3 is about 0.666666. It's a recurring decimal. And let's put it to 2 decimal place or 3 decimal place. It will be 0.667 kilometers per minute. Alright, so that's what we got. S1, S2, S3. So you could see, my dear friends, from here, what does it tell you? That the first 8 minutes, the speed was 0.625. Alright? 0.625 is about 6/10 about their estimation. In S2, it is 0. In S3, it's about 0.66. Hey, that's S3. So that's a bit faster, a little bit faster. Right? So now, from this graph, we're going to draw the speed time graph. It's called a sketch. Alright? Means a sketch means it's just an approximation. And this time is in minutes. And this is the speed and the speed is in kilometers per minute. You've always got to be very careful with the axis. Tell them what it is, so whoever marks your work knows what it stands for. For example, if I don't know you and I call you, hey, 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 hello, A, B, that's rude, right? So just like that in the graph, if you don't put anything, who are you? Who are you? So you got to say, I'm speed. And what speed? What type of measurement? Is it meters per second? Is it meters per hour? All right. Oh, I'm kilometers per minute. So it tells volume. You get what I'm saying? And I don't know your name, but I call you dear, and I like you, and I want to give you my best. All right? I love children, and this job is beautiful, especially teaching maths, my favorite subject. Because when I was young, my dad made sure I had every bit of it, and every time I couldn't get it right, he took the leather whip, ow, and I'll jump. But every spare the rod and spoil the child, they say. My dad did not spare the rod on me. He did it, and he did, and today I'm grateful to him because I'm a maths teacher right now. So remember what your parents do to you. It's for good reasons. Okay? Don't get angry. Don't feel bitter. Smile. Good people care for you. They will tell you off. All right? Great. So let's look at the sum again. We have speed and time. So in the first 8 minutes, I should put here 8, then 12, and then we have 18. Right? As I said to you, it's a sketch. So it is not a very accurate sketch. Now then we have, for the first 8 minutes, it was a constant speed. Maybe I put this as 0.625. So this was the constant speed. All right? And then it went to 0 from S3, it was 0. S2, sorry, it was 0. So here is 0. Let me use another color. This is this, and here, yep, and we put a dotted line. And then it went up to 0.666. It's a recurring decimal. All right? So what do we write here? This is 0.667. A little bit of a round up. Can you read that writing of mine? So this speed here is 0.667 kilometers per minute. So the graph here, the speed time graph, is in kilometers per minute, and it's showing you the different speeds. All right? At this point, from 0 to 8 minutes, the speed is constant. That's what they ask you to comment. So this is what you write. Okay? From here to here is a constant speed at 0.625 kilometers per minute. The next part, from 8 to 12 minutes, there is no speed. The speed is 0 because no distance is moved. As for 12 to 18, the speed is constant at 2/3 kilometers per minute, because this is moving on and on. This is a more exact answer. So you could say that, all right? 2/3 kilometers per minute. But because I write 0.667, because this is been in decimal, so I just wanted to be shown. Okay, as for the distance time graph, you can say that they covered a distance of 9 kilometers in 18 minutes. 9 kilometers in 18 minutes. So the average speed will be, all right, average speed for here will be 9 kilometers in 18 minutes, which will be half a kilometer per minute. That's what this graph is telling us. And of course, you have to read the information. There's no such thing as area under the graph. Please do not get confused. That was the speed time graph, which we're going to do shortly. Here, the area under the graph is nothing. All right? It's just the slope that is showing us the speed. And the speeds are changing. All right? There's no speed here. That's all. And when the speed at every point here, the speed is the same. It's a constant speed. And here's 0, and here again, there's every point from 12 to 18 minutes. If they ask you, hurrah, 17 minutes, what's the speed? It's the same, 2/3 kilometers per minute. All right? If it's 5 minutes, what's the speed? It's 5/8 kilometers per minute. Got that? Great. Let's move on to the next sum, question 4. Okay? So you see how beautiful speed time graph is. What you require is to know how to read the graphs right. Translate the picture of that graph into information. That's why I'm trying to focus on this important information. And of course, if you think about like the earlier sums that we did in our techniques, take them as working drill. Look at it, how two people catch up. Remember the Greenwich, father catching up the daughter. That's a distance, all right? And this is a speed time graph with distance. Look at it, it's beautiful. The next sum will be something like that, which I'll be giving you in the question 5. But look at question 4. I want to reinforce, all right? Look at it again. This is speed, kilometers, time, minutes, all right? Speed. And I purposely took information, something like that, the same thing, and I'm repeating it here, but to tell you they're totally different. All right, look at it, speed and time, 8 minutes, 12 minutes, 15 minutes, and 18 minutes. And then here is 5 kilometers per minute. That's the speed. It's not the distance. And this is 9 kilometers per minute. Sorry, I've got that not written right properly. I'm sorry about that. Oh, Kumar, come on, yeah. All right, speed, because it's kilometers per minute. Speed cannot be in kilometers, that's distance. Look at this graph, and I want this comparison with this graph, this question. This is distance against time. And here is speed against time, and I'm following similar, same measurements about there to show you the differences. Now what they ask you from the given speed time graph, they want you to find the distance time graph, draw it, and they want you to draw the acceleration time graph and comment on the two graphs, A and B, the distance time and the acceleration time. Are you all right with that? Great. Now the area under the graph plays a vital role. That's the distance traveled. So if you look at this, I'm going to put up 4 distances. All right, this is A1 from here to here. Here to here is A2. All right, this is A2. And then I look at this part here, A3. And then I come to this part, A4. Ha! We've got to find out the area, the total area. And each part, you look at this, there's a speed here. The speed is changing. It's not constant. It's not constant. From 0, it went up to 5 kilometers per minute in 8 minutes. So there is an acceleration here, A1. Here the speed is constant, so the acceleration here is 0. And here A2, here the acceleration from 5, the speed from 5 kilometers per minute went up to 9 kilometers a minute in 3 minutes from 12 to 15. So we want to find the acceleration A3, and in here from 15 to 18 minutes the acceleration is constant, A4. Now let's first do the distance, all right? Look at A1. Green pen, where are you? Green. So question 4, we look at A1. It's a triangle, and that's 8 and that's 5. So base times height divided by 2, you get 20 kilometers. Traveled in 8 minutes, traveled in 8 minutes. Got it? So that's the area traveled, because look at that, kilometers. So be very careful. If that had been meters, then you have to write it in meters. Alright, so be careful how you label what you write. If I call you another name, you won't like it. So you like the name that you're given, or maybe the name that you created. What's your name? Alright? Okay, let's look at that. 20 kilometers. What is A2? A2 is a rectangle. And what is this rectangle? There's 8 to 12, which is 4. 4 times 5. Ooh, looks the same, the area covered. So it's 4 times 5, and that is another 20 kilometers covered. Great. And then what is A3? A3 is a trapezium. What is A3? I'm following the colors of the chalk that's written here. From here to here is 5. Here is 9. So you add the parallel sides, divide it by 2, and then the height from here to here is 3. So you got a 14. 14 over 2 is 7. 7 times 3 is 21 kilometers traveled in A3. What about A4? A4 looks like a decent rectangle. So A4, alright, this is 3, length times breadth, and the height is 9. 3 times 9. So that's 27 kilometers traveled. Ooh, so these are all the various distance traveled. 20 kilometers, another 20, another 21, and another 27. What is the total distance traveled? Let's branch out a little bit different. What's the total distance? The total distance will be 20 plus 20 plus 21 plus 27. We've got 88 kilometers traveled. In how many seconds? In 18 seconds. Got that? So, if you want the average speed for the whole thing, alright, will be 88 over 18 divided by 2. You get 44 over 9 kilometers per minute. Almost 5 kilometers per minute. This 45 over 9 is 5 kilometers per minute. Now, let's look at the sum again, that distance time graph. We're going to draw it out. Okay? We're going to say, hey you, this is distance and this is time. Distance is in kilometers and the time is in minutes. Alright? And we've got up from here to 8, and then to 12, and then to 15, and to 18 minutes. Now, is the speed constant? No. The speed is not constant. It's changing from 0 to 5 in 8 minutes. Alright? So, but the distance traveled is 20 km. So let's look at it. A20. So this is an increasing speed. Increasing. Take note of that. Now here, in A2, which you have traveled another 20, is the speed constant? Yes. Alright, the speed is constant, is fixed at 5 kilometers per minute. And you traveled here another 20. So 20 plus 20 is 40. So we look at it here again, it's a constant speed. So constant, you draw a straight line. Got that? Good. Now you look at this part again, A3. Alright, in 3 minutes, you travel 21 kilometers. Another 21. So 40 plus 21 is 61. So we said, hey, you 61. Alright, in 3 minutes. So I'm going to draw this graph here, 3 minutes. Hey, it's increasing speed. Look at the shape. This is called increasing speed. Ooh, alright, it's an exponential increase. And then we look at the next part, A4, 27 kilometers in another 3 minutes. But look at the speed here, it's constant. Alright, it's constant. So another 27. So you add another 27. 27 plus 61 is 88. And that's here. And that's a constant speed. So look at the graph, my dear. Straight. Straight. Alright? So you see this curve? That's called an increasing speed. But if it's a decreasing speed, it will be the opposite way, like that, dropping. If the speed had been like coming down. Alright? So then it will be opposite, but you still add to the distance. Take note of that. Okay. Now, if you look at this again, so this is called the distance time graph. Got it? Let's look at the acceleration time graph. Now, what is the acceleration time graph? Okay, be patient. Look at A1. What is A1? The acceleration. Is there an acceleration? It is 5 over 8. 5 over 8 what? Kilometers per minute square, which is 0.625 kilometers per minute square. Alright, that's A1. In A2, what can you say about A2? A2, there's no acceleration. Alright, A2 is 0. 0 kilometers per minute square. Alright, that's A2. This is A1. Take note of it. Alright, in A3, from 5 to 9. Alright, that's about a speed jump of 4 kilometers. In how many minutes? In 3 minutes, from 12 to 15. So look at that. This is 4 over 3, which is about 1.1/3, you know. 1/3 is 333. Alright, with a dot actually is a recurring decimal. Kilometers per minute square. Got it, everybody? That's A3. And look at A4. A4 is a constant. So A4, the speed is the speed is constant. There's no increase. So the acceleration is 0 kilometers per minute square. So that's what you get. Have you got that? So it's so easy to draw the graph. You get it? Okay, draw that. And then you said, okay. And this is acceleration. As I told, write the label clearly. And the units, very important. Okay, acceleration. And the time, is it in hours, seconds, or minutes? Please write that. And then specify 8, 12, 15, 18. So what is the acceleration in A1? 5/8. Alright, there's a constant acceleration here, 5/8, which is about 0.625 kilometers constant up to here. Dotted line. Alright, take note. Not very neat, Kumar, not very neat. You know, when you're standing and you're writing, not very nice to write. Alright, in A2, it's 0, 0, A2. Here, 0. And then A3, look at the speed, is 1 and 1.33. Hey, 1.33. So from here to here is 0, and from here to here is 1.33. So do a dotted line here, Alright, so this will be the speed. And then A4. A4 is 0 again. Yeah, got it. So you've got and all the time, the speed is increasing. That's why you see positive numbers. But if the speed was decreasing, alright, you will see a deceleration. And if it's dropping, then the deceleration, the lines will go below. It's a minus. So that's when we do it, alright, in the earlier Psalms. So I hope this gives you a better understanding, alright? And they ask you to comment on it. When I was teaching, I was commenting a lot on it. And I'm sure you can be able to comment. The fastest acceleration here, the driver was in a hurry. What reason? What reason you think? I think he needed to go to the toilet. needed to. Possible. Needed to go toilet. What other reason? Late for an appointment. With who? With a girlfriend. Hey, I told you guys. Alright? Okay, so here he was accelerating. And then steady speed when he reached his speed. Okay, so this is a beautiful sub on how you change a speed time graph to a distance time graph and acceleration time graph. There's a lot to see in how you see an increasing speed. Alright, in a distance time graph, the slope is telling you the story of the graph, and there is so much. A picture is worth 1,000 words. Here's an increasing speed, a constant speed, an increasing speed, and a constant speed. Now look through this very carefully, my dear, and you would have a better understanding. We'll come to fifth sum. Now just before that, stretch yourselves, get out of your seat, and move on, and we'll come again. Right? Question 5.